We're good.
Okay, cool. Your light bulb word could be equal for solve an equation. That would be an easy one. All right, this one, reciprocal of a number. Kids also always miss this one. So I'm gonna start with the example. So let's do 2/3 because you had 2/3 A on one of your Delta Math assignments. So when you're finding the reciprocal, it says right here U, and it got cut off again. I gotta figure out why that did that. But you flip the number. So if I flip 2/3, what would the reciprocal be?
3/2.
3/2. Did y'all learn that in middle school?
Yes.
Perfect. So usually when I did my cards for this years ago, when I first started teaching Math 1, I did my synonym as flip, and then I just did an example like this. But a reciprocal is where you either flip the number or you do 1 divided by the number. So let me give you an example like that. If you have 2, there's nothing underneath a 2, right? 2 is a whole number. It's not a fraction. So you can't really flip a 2 because it's a whole number. So to find the reciprocal of a whole number, we do 1 divided by whatever the number was. Your middle school teacher might have taught you that there's an understood 1 underneath this, and then you could flip it. That's good too. Am I going too fast or we're okay?
We're okay.
Okay, good. So y'all don't, again, you don't have to write these, just kind of pay attention. It would be good to write, or you can just watch the video again later when you're doing your cards. Literal equation is an equation with only variables and operators. This is what we're gonna start on Friday. So I always have a kid be like, how do you have an equation with only variables? So let's talk about it. In middle school, did you guys see this equation? Let me write it right here. Did y'all see that in science?
Not really.
Okay, what about this one?
Yes.
Yes. That's the formula for what?
Length times width.
Which finds the, what's the A stand for?
Area.
Good, very good. Extra credit, Gwyneth. Area. So area equals length times width. That is a literal equation because it's an equation with only variables. We're going to do those on Friday, okay? But there's an example. A lot of times my kids make their light bulb word letter because if it only has variables, then it's going to have letters, right?
Yes.
Yeah. And then rate of change. I think y'all learned rate of change in middle school. I hope. Rate of change is just another word for slope. Y'all talked about slope in middle school, right?
Yeah.
Yeah.
Okay, good. The rate of change is just slope. So you could make your light bulb word slope. You could make it change. You could make it rate. All of those mean the same thing. Are y'all okay with this vocab?
Yes.
Yes.
And then we're not doing bonus words. I normally do, but you guys have open notes vocab since we're virtual. So I'm not doing bonuses. Okay? All right. If y'all are good, we'll go ahead and do the notes today. They're very short. We're doing more solving. I did have somebody send me a message yesterday, and they were like, I'm not good at remembering steps. Do you have another way to help me solve an equation? So we are going to write that down, but then we've just got examples, okay? All right, y'all. Let's go ahead and get started. Y'all unmute and participate. Some of you have been doing awesome already, so you get your extra credit. So today we're going to be talking about solving multi-step equations and inequalities. And I'm going to just abbreviate if that's okay with y'all. All right, so solving multi-step equations and inequalities. Instead of steps, we did write steps yesterday. So if steps work for you, by all means, y'all like follow those 1, 2, 3 steps we wrote. But I do also want to talk about it this way, because I know I have a lot of my, especially my blue people and my orange people, y'all might like this better than trying to remember steps. My gold and green people, y'all can usually remember steps good. But if you were blue or orange, you might like this better.
How do you know if you're blue or orange?
Did you take your true colors test? You
Yeah.
did. Do you remember what color you were?
Orange.
Orange. So orange, blue and orange people are usually very visual. So you guys aren't always the best at remembering steps, but if I give you like a picture or something like this, you'll be able to visualize what each letter stands for.
Okay.
Yeah. I'm blue and this works better for me than steps. All right, so solve. Does anybody know what a poem that goes down with the letters like this is called? In case you couldn't tell, I also love English, so I always tie them together.
Acrostic.
Good, Gwyneth. Good job, girl. This is an acrostic. We're going to write an acrostic poem for solving equations, and I can already see Curtis at home rolling his eyeballs. What you think, Amaya?
He probably is.
Yeah. He's like, why is Miss Poole always picking on me?
What I do?
So the S is going to stand for same side simplify. So multi-step equations get kind of tricky, y'all, because there are multiple steps. Like how we wrote out step 1, 2, 3 yesterday, there might be multiple things you have to do before you can start step 2. So multiple things in step 1, multiple things in step 3. So multi-step equations get tricky. So S is going to stand for same side simplify. O is going to stand for one-sided variables, which basically means get your variables on one side, okay? L is going to stand for locate and cover variable. So notice how that's just one. So when you get them all on the same side, you should be able to combine them and just make one variable and then cover it, okay? All right, V is going to stand for variable by itself using inverse operations. And then the last step, I had somebody send me this in a text yesterday on Remind, and it was a great question. They asked if there was a way to check your work for solving. So I am going to show you guys how to check today, okay? So that last step is examine/check. And then after we solve this one, I'm going to show you how to check your answer to make sure it's right, okay? All right, what's the very first thing we should do, y'all?
Their wall.
Good, draw your wall, good job. So draw your wall. Now, when you look at the two sides, what I mean by same side simplify, look on the left. Is there anything on the left we can combine or put together?
The 9 and the 4.
Okay, be careful.
Now we just covered the up top numbers and use the 4 minus 4.
Good, Dave. Okay, so
Times 4, right? Hold on.
right, you're right. Good. So you can't combine any of those because the 9 is being subtracted from the 3x. So since it's up here with the x, we can't do anything with the 9 and 4. So then you look at the right. Well, we can't put anything with 3. It just says 3. So we can't same side simplify on this one, but on some of these next ones, we're going to be able to simplify first, okay? So now I want to try to get the variables on one side. Do I have more than one variable?
No.
So
Wait.
that doesn't apply to this one either. So let's skip on down to the L. Locate and cover the variable. So what David said was the X is in the top. Do y'all remember doing one like this yesterday?
Yes.
Yeah.
So I'm going to cover everything in the top. And what's left that I need to move says divided by 4. So how am I going to move that?
Times 4.
Good job. So times 4 on both sides. And what happens with these two?
They cancel out.
Here, they're going to cancel. So does everybody agree I'm left with 3x minus 9? And Curtis, what's it going to equal?
12.
Good job. I don't know that was Curtis.
Hmm.
Was that you? That wasn't you that answered.
No, that
No,
was
that was me.
Okay. 3x minus 9 equals 12. Are y'all okay there?
Yes.
Okay, so now I want to get the x by itself. So I'm still on locate and cover. I'm going to cover the 3x. What do I move next?
9.
9.
Good. Amaya, I heard your voice. How do we move that 9, babe?
You gotta do plus 9.
Good girl. Add 9 to both sides. Sorry, I didn't mean to say good girl like that. That made it sound like I was talking to my dog. You know I didn't mean that bad, right?
21.
Good, David. So 3x equals 21. Y'all are okay?
Yeah.
Okay. So Curtis, I want Curtis to answer. What's the last thing I got to do to get that x by itself, babe?
Divide by 3.
Good job. He was like, that's too easy. Make it harder. Okay, Curtis, we'll make the next one harder.
No, don't make it hard.
Did y'all get 7?
Yeah.
Okay, good. So this is like ones that we've been doing. Now, I do want to show y'all how to check. To check your work, because we just did cover variable and we did inverse operations to get the variable by itself. So now to check your work, you can take that x equals 7 and go plug it in where?
Where the 3 is.
Beside the 3, where the x is, right? Good. So everybody watch. To check your work, I'm going to check it right here. And I want y'all to write this with me so that when you're taking your test, you can check your work and know if it's right. When you're solving equations, you should always know if you got it right or wrong. Okay? So instead of an x, I'm going to put in a 7. So I've got 3, and then instead of x, I'm going to put in parentheses 7 minus 9 over 4, and it should equal that 3 that we started with, right?
Yes.
Okay. Did y'all learn this in middle school?
Yeah, I think so.
Yes.
Okay, some of you did. I heard some no's too, though. So some of us did not. This is the best way to check your work on these. 3 times 7, because I got to do parentheses first. What's 3 times 7?
21.
21 minus 9?
12.
Good. I was about to say count on your fingers if you got to. So look, is 12 over 4 equal to 3?
Yes.
Yes. So we know we did it right. The answer is 7. If it works out to be a true statement, then you did it right. Does that make sense?
Yeah.
All right. Are y'all ready to try another one?
Yes.
Yeah.
Let's do it. Hopefully I have enough room down here. I'm going to try to write a little smaller. Example 2, let's do 6 plus 2. I'm going to use a different letter. N minus 10 equals negative 2 n minus 3. All right, Curtis, here we go. Here's one of those longer ones we were talking about.
I don't like this.
Don't say that. I got you. Don't do that. You said up here, you said 3 really fast, so I had to make it harder. This is your fault. All right, what do we do first?
A parentheses.
Ooh, be careful. Very first. You are right.
Wow.
Wall, good. Now, I love what Gwyneth just said. Let's talk about it, y'all. Your parentheses, we did one like this yesterday. You cannot cover your ends yet, and there are 2 of them, so we're going to get into those solve steps that we wrote down. You can't get to these to cover them yet, though, because they're in parentheses. So this is exactly what I mean when I wrote up here, same side, simplify. Look on your sides. We'll do the left side first. And we need to simplify this before we can get our ends together, okay? Before we can cover them up. So, Gwyneth said we need to do parentheses first. Can you do n minus 10?
No.
No, please do not write negative 10n. Wrong. Think about what we talked about yesterday. Visit the zoo. You cannot put, I can't think of an animal that starts with an N. Narwhals. That's not a real thing though. That's just an elf. Anyways, you can't put 2 different types of animals together at the zoo. It's not going to work out, okay? So how do we get rid of these parentheses?
Distribute.
Good. Do you guys remember yesterday we distributed?
Yes.
Okay, good. I hope so. It ain't been that long, y'all. It's been 24 hours. Distribute. So when you distribute, remember, you're just multiplying whatever's outside into all the things in the parentheses, and then you can get rid of the parentheses. So I'm going to bring down the 6 because I'm not touching that. So now I've got positive 2 times n. Does everybody agree that's going to be positive 2n? Are y'all okay with that? Okay.
Yeah.
Okay. So now look, positive 2 times negative 10. What is that going to give you?
Negative 20.
Negative 20. Good job, Gwyneth. So minus 20 equals. Now we did the left side. I want y'all to look at the right side. How do we get rid of these parentheses?
Distribute.
Distribute. Good, Kiara. So distribute your negative 2. So what's negative 2 times n?
Negative 2n.
Negative 2n.
Good. Negative 2n. What's negative 2 times negative 3?
Positive 6.
Positive 6. Good job. All right. Let's see if we have simplified everything now. So I'm going to do the same thing I just did. I'm going to cover the right for now so we can just look at the left. Is there anything on the left-hand side that we can combine?
The 6 and the 20.
26.
Okay, good. The 6 and the negative 20. Not the 2n. That's got to end, so it's got to stay by itself. But these 2 right here are just plain numbers, right? So can I combine those?
Yes.
Okay, what is 6 minus 20? If you put a positive 6 and a negative 20 together, what are we going to get? So think about the signs. They're different.
Negative 14.
Good. So everybody look, they're different. Positive 6, negative 20, different signs you subtract. 20 take away 6 is 14, and the bigger one is negative. So does everybody agree? I'm going to bring down the 2n, and then I have minus 14. Are y'all okay with that?
Yes.
Okay. So now on the right side, can we combine these?
No.
No. Good, Kiara. No. So I'm going to bring them down. Negative 2n plus 6. Phew. Curtis, we already done a lot of work, haven't we?
Sure have.
Not too bad, though. If you cover the sides and just do one side at a time and simplify, this looks a lot better already.
Mm-hmm.
All right, so now I want to talk to y'all about this. There's 2 ways you could go from here. We just did same side simplify. So now it says one-sided variables. You got to get your variables together on one side so you can cover them, okay? So 2 ways. Some of your middle school teachers taught you to move everything to the left, maybe. Maybe not. Y'all aren't answering me.
Yeah, they did.
They did teach you to move the letters to the left? Okay. The other way is you can move the smaller letter. I'm corny, so I like to move the letters to the left. Y'all know what the cha-cha slide is, right?
Yes.
Okay, I always tell my kids, take your variable, slide to the left. Y'all with me? So I want to get all my variables on the left. All right? So how do I move this negative 2n over here to the left?
Plus 2n.
Plus 2n. And what you do to one side, David, I got to do to the
Other.
other. And y'all look, it has an n, so I'm going to put it with the other n's. Does that make sense?
Yeah.
All right, slide to the left. I need y'all to remember that. You can sing it if you want. But cha-cha slide to the left with your letters, okay? So what's 2n plus 2n?
4n.
Ooh, good, 4n. Minus 14, because I didn't use that, so I'm going to bring it down, right? Equals, and I'm going to bring down the 6. Now, Curtis, this part should look easy. Was that a huh, or was that a uh-huh?
It was a huh?
Whoa. Amaya, why am I telling him this should look easy?
Oh, yes, easy.
What's this third step?
Locate or cover the variable.
Cover the variable. Where's the variable, Curtis? There's only one now. We moved the other one.
The 4n.
4n covered up. Amaya, how do I move that 14?
Plus 14.
Yes,
on
ma'am.
both sides.
Plus 14. Good job, baby.
20.
Good. I'm running out of room. Are you guys okay if I come right here?
Yes.
Okay, so are y'all getting what me and David are getting? 4n equals 20?
Yes.
All right. So, Kiera, what do we do now, babe?
Divide.
Good. Divide by
4n.
just the 4, but good. So, n is going to equal
5.
Good job. Now, Curtis, it wasn't that bad. The hard part is at the beginning, right?
Yeah.
Yeah. If you can get that beginning part where you simplify on both sides, then you should be good. Because then we're going to take our variables and slide to the left, combine them, and then cover up and everything else we've been doing.
All right.
All right? Can I give y'all one of these to try on your own? I'm going to be sitting up here so you can ask me a question.
Yeah.
We're not done, so don't leave. But can I give y'all one to try on your own?
Yeah.
All right, y'all try this one. I'm going to flip the page if there's no questions. Oh, really quick, hang on. The ADHD is real. How would you check this? Where could you go put this 5?
With the n.
With
But
both?
not the 2.
Yeah, but put it with both of them. So you would do 5 minus 10. I'm going to count in my head. That's negative 5. And then you'd multiply by 2 and add 6. And you would see if whatever you get over here equals 5 minus 3 is 2. Negative 2 times 2 is negative 4. You can just plug it in to check. Does that make sense?
Yes.
Okay, we'll do it on this next one to make sure everybody understands. All right, I want y'all to try this one. Example 3. All right, here y'all go. 3 minus 2 times 4x minus 9 plus 6 equals 5 times 2 minus 4x minus 3x. I know it's a lot. Just try it. I'm going to stop the recording. All right, same side, simplify. So I'm going to cover up the right side for now, and let's just look at the left. So on the left side, did you guys distribute first to get rid of these parentheses?
Yes.
Okay, so we take negative 2, multiply it by 4x. What does that give me? It's negative 2 times 4x.
-8.
Negative 8.
X.
X, good. The rest of y'all better start chit-chatting or I'm going to cut the Zoom short. Negative 8x. What about negative 2 times negative 9? What's negative 2 times negative 9?
Negative
18.
Positive 18. Good. Remember, a negative times a negative, when the signs are the same, they'll cancel. So that's going to be positive 18. Now, what did y'all do with the 3 and the 6?
I brought it down.
Good. You should have brought it down. Very good. I'm running out of room because I got this tape thing over here. Okay, if it's okay with y'all, I'm going to keep simplifying on the left side because I see some stuff I can put together. What about y'all?
Yeah.
Yeah, I see a 3. I see a positive 18. So I know I can do 3 plus 18. And then I also see a positive 6. So can y'all add 3 plus 18 plus 6? They're all numbers. There's no X's. So I can put them together. So what's 3 plus 18 plus 6?
27.
Good, David. I counted on my fingers. That's totally okay. I also got 27. So everybody look, we're going to have negative 8x. Daggone this daggone pen. Negative 8x. And then all of these are positive. So it's going to be plus 27. Now, Curtis, don't that look a lot better?
Yeah.
Yes. Did anybody get negative 8x plus 27?
Hmm.
Yeah.
Okay, I'm here too. My girls, y'all didn't get negative 8x plus 27?
I got it.
Oh, okay, good. Y'all didn't answer. Good. All right, let's cover this. I'm going to use something else to cover. Oh, that was better. Okay, cover the left. Let's simplify on the right side. Did you guys distribute the 5?
Yes.
We got to do parentheses first. So 5 times 2. Did y'all get
And
good? And then 5 times negative 4x. What did we get?
Negative 20.
Good. Negative 20. X.
X.
Good. And then did you bring down the negative 3x?
Yeah.
All right,
Yeah.
look at y'all. Okay, okay. So now, like I said, this is the hard part. What can we put together on this side?
Negative 20 and negative 3.
Good. The negative 20 and the negative 3 both have an X. Now, the signs are the same, which means I can add them, right? So what's 20 plus 3?
23.
23, and it should stay negative, right? Because you're just
Yeah.
putting them together. So did you guys get 10 minus 23x on this side?
yes.
Okay. Okay, y'all, that is the hard part. If you can get there, we should be okay. Now I've got to take my letters and slide to the left. Is everybody with me?
Yeah.
All right, so the left is this way. So I need to move this negative 3 or negative 23x over to the left. How do you move a negative 23?
Plus 23.
We're going to add and make sure you take that x with it because they're together. They're married. That's what I used to say anyways. I'm going to take them, add it, and slide it over here to the left with the other x's. So now I've got negative 8x plus 23x.
15x.
Good. Different signs. So we should subtract. 23 minus 8 is 15. And guys, which one of those numbers is bigger?
23. So positive.
Good. So it's going to be positive. Good, David. David, you should be a math teacher.
Nah, I don't want to be no teacher. That's too hard.
Oh! It's such a rewarding job, though, when you got good kids like y'all that join Zoom. All right, Curtis, this should be the easiest part, boo. What do we do next?
I'm out of breath. Hold on.
Why are you out of breath?
Cause this math making me get out of breath, make my ass up.
Amaya, help your friend. What am I doing to the camera?
Cover up the.
Cover. There he goes. He didn't need your help, Amaya. Cover the 15x. Jayla, what am I going to do with this 27, babe?
Add it to 10.
Okay, be careful, not add. It says add. What we do?
Subtract.
There you go, boo. Good job. Subtract 27 on both sides. Are y'all with me and Jayla?
Yeah.
Yes.
17.
When y'all get here, y'all better get this part right or I'm going to be mad because this is the easy part we've been doing. So look, positive 10 and negative 27, different signs you got to subtract. So y'all, 27 take away 10 is what?
Negative 17.
Oh, yes. Amaya, good job, babe. It's negative 17 because look, your bigger number was negative. Good job. And so all I got left now is 15x equals negative 17. How do you get x by itself?
Divide by 15.
And this is why I said I got a fraction. Can y'all do 17 divided by 15?
No.
Oh, so what do we do, Kiara? What do we do?
I forgot the word. Oh my god.
Simplify it.
I want y'all to go type that in a calculator and get some long tail decimal.
We simplify it.
Okay, good. Don't go type it in a calculator. If these are on your exam, they're going to be on the non-calculator, okay? You simplify, except these don't have anything in common, do they?
No.
Because my factors of 15 are 3 times 5, and 3 does not go into 17, and neither does 5. So what if you can't simplify? What do we do? Ooh, y'all.
Keep it how it is.
Yes, leave it. Leave it. Negative 17 over 15 works for me. Leave it. I don't want you trying to divide that off to the side. You don't need to do that. Leave it. This is the hardest one you could see. So Curtis, do you feel better with me telling you this is the hardest type you can see?
Yes, thank you, Jesus.
The hardest one, it's not going to get harder. This is as hard as it gets. And y'all did pretty good with it. So now I just got one more thing to show y'all and then we will be done. Sound good?
Miss Paul,
Yes.
one question.
What's up, babe?
When we moved 23 to the left, can you
Yeah.
tell me how come we couldn't move negative 8?
You could have moved negative 8. If you want to move the smaller number because that math is easier for you, you can definitely do that. I don't move the smaller one because I do better when all the letters are just on the left, because then it'll always say like X equals or X greater or X less. So I like to slide to the left. That's just easier for me to remember because it goes with a song. But if you want to move the smaller number, like 8, it's easier for you to move 8. You could have moved the 8. Let me show you. Are you okay if I show you real quick?
Yes.
All right, I'm gonna grab a different color. I'm gonna do it right underneath it in black. So you could have added the 8x, and those would cancel, right? And then add the 8x over here with the negative 23. So same thing, different signs. So you would subtract. 23 take away 8 is 15, but this time it's gonna be negative, right? Because the bigger one's negative. Are you
Right.
okay? So then you would have had 27 over here equals 10 minus 15x. So same thing now. I'm going to cover the 15x. The 10 is positive, so I would subtract it, right? If I'm going too fast, Jasmine, you let me know. Are you okay with that part, babe?
Yes.
Okay, so then 27 minus 10 is 17 equals negative 15x. And watch, divide by negative 15, divide by negative 15, you get the exact same thing we got. So that's why I said if it's easier for you to move the smaller digit, go ahead and move it. If that's easier for you math-wise. I just like to slide to the left. But either way, okay?
Okay.
Curtis, why does it work both ways? He's like, why are you calling on me? You want me calling Amaya instead?
Yeah, call on her.
Amaya, why does it work both ways? What do we know about a seesaw? What did I tell y'all? All right, y'all, if somebody real heavy gets on one side of the seesaw, what's going to happen to this person?
Live out the way.
They going to shoot up, right? I told y'all I had a kid last year that had never ridden a seesaw. That was wild to me. My little cousin used to be real chunky when we were little, and it was fun to ride a seesaw with her because you would shoot up real quick. A seesaw should end up equaling. It should balance if you got the same thing on both sides. So since both sides should end up equaling, it shouldn't matter where you move things, as long as what you do to one side, you do to the other. Does that make sense? I hope.
Yeah.
All right. So let me show y'all one more thing that could happen. Example 4, and then we're going to be done because y'all have done a great job today. I'm going to give y'all extra credit because we've all been doing super good. One more thing that could happen. I want to show y'all something like this. This is going to be an easy one, Curtis, okay?
Okay.
He said, thank God. All right, y'all copy this one down. 4 times m minus 1 equals 4m plus 2. All right, y'all ready?
Yes.
What do we do first?
Draw the seesaw.
Distribute.
Draw the wall, and then David said simplify on your sides. So look at your left side. I got parentheses. How do I get rid of those?
Distribute.
Distribute. Are you guys with them? So I got to do 4 times m, which is
4m.
good. And then 4 times negative 1.
Negative 4.
Good. Good job, y'all. Equals. Is there anything to simplify on the right?
Nah.
No, Curtis, I gave you an easy one. 4m plus 2. Just bring it down. So you did your same side simplified. Now remember, the O means one-sided variables. So I got to move all my variables to one side. Are y'all okay if I just slide them to the left?
Yeah.
Okay,
Yeah.
so let's look over here. I need to move this 4m over to the left. So how do you move a positive 4m?
Subtract.
Minus. Hold on.
Minus 4m. Those cancel. Minus 4m. Let's see what y'all remember. What happens?
That's m, I think.
Not m. What's 4 take away 4?
0.
0, but like, how you gonna take m away?
Exactly. So stop. I love what he just said. Everybody look. Does everybody agree 4m take away 4m? You ain't got no m's left, right?
Yes.
Okay. He said, how are you going to just take m away? We didn't take it away. It went away on its own. So look at what you have left. Negative 4 equals 2. Is that a true statement? Y'all, come on. That's an easy question. Does negative 4 equal 2?
Yes.
Where's Amaya? Amaya. She's like, please don't call on me. I don't want to talk anymore.
Yes.
Huh?
There you go. I'm asking you and Jayla. Does negative 4 equal 2?
No.
No. So what do you do if the m's just go away and you're left with something that is not true? What's the answer then?
Negative 4 over 2.
Nope, because we ain't got no m's. You can't divide.
0.
Huh?
0.
Nope, not 0.
It's on the paper, bro. It's not true.
It's not true. So what do we write? Is there an answer?
No.
No.
Call it when there's no answer.
Inaccurate.
Oh, y'all didn't learn this in middle school? I'm
I
so,
don't remember the name.
I ain't mad at y'all. I'm irritated with your teachers, but it's okay. You should learn it. No solution?
Oh yeah, we did learn that. We did.
Okay.
We did. I just forgot.
Okay, so y'all did learn it. All right. If the variables go away and you're left with something that is not true, You write no solution. Now listen to me very carefully because every year I have a kid do this. If you get to one like this, Curtis, don't you decide that, oh, that just looks too hard. I'm just gonna write no solution. I had one little boy in the fall. It was my boy that got a 17 in R2. That boy talking about some no solution for all 10 of them and turned the test in 7 minutes. Yeah, you can laugh. It was stupid. Don't you just, no solution for all of them because you're being lazy. No, this does not happen often. Think about all the examples we've done and this hasn't happened yet. It happens occasionally, very rare, but it might happen. If your variables cancel like they did here, when I tried to move them, they vanished. And you're left with something that's not true, it's no solution. What if you're left with something that is true? Anybody?
I forgot the name. It's like equal sides or something like that.
Kind of. So if the variables cancel and your sentence is true, we call that infinitely many solutions, which means any number you can think of would work. Did y'all learn that in middle school?
Yeah.
Okay.
My teacher just put many solutions.
Many solutions is perfect, Gwyneth. You don't have to put the infinity sign, but technically it's called